My dear students, in the previous video, I have started the properties of determinants and I derived two properties with examples. The first property, if we interchange the rows and columns of a determinant, the value of the determinant is not changed. That is the first property. Second one is, if any two rows or columns of a determinant are interchanged, the sign of the determinant is changed. These two properties you have seen in the previous video. In this video, the third property, if any two rows or columns of a determinant are identical, any two rows or columns of a determinant, two rows or two columns are same, then the value of the determinant is 0. See, consider the delta. First row A1, A2, A3. Second row is also A1, A2, A3 because the two rows R1 and R2 are identical. R1 is identical to R2. Therefore, C1, C2, C3, third row as it is you have. Expanding this along R1, A1 into A2 C3 minus A3 C2. A1 into A2 C3 minus A3 C2. Next element minus A2 into A1 C3 minus A3 C1. You eliminate this column. A1 C3 minus A3 C1 plus A3 into A1 C2 minus A2 C1. Again multiplying A1 A2 C3 minus A1 A3 C2 minus A1 A2 C3 minus into minus plus A2 A3 C1 plus A1 A3 C2 minus A2 A3 C1. Just I am multiplying with A1, A2 and A3 and I get this expression. See here A1 A2 C3 plus minus A1 A2 C3. These two terms cancel. And minus A1 A3 C2 plus A1 A3 C2. These two terms get cancelled. Plus A2 A3 C1 minus A2 A3 C1. The terms are cancelled, we get 0. So delta value is 0. So if any two rows, similarly columns are identical, then the value of the determinant is 0. This is the third property and we will justify this property with an example. Okay. Consider, for example, for a determinant delta whose two columns minus 1, 3, 2, 4, 1, minus 3, 2, 1, 0. You consider this determinant. In this determinant, two rows you have to consider as equal rows. Therefore, the second row is also is minus 1, 3, 2. R1 and R2 are identical. Okay. Now expanding through R1, delta value is minus 1 into 3 into 0, 0, minus 1 into 2, 2. This is minus 3 expansion, eliminating this. Minus 1 into 0, 0, 2 into 2 minus 4, plus 2 into minus 1 into 1 minus 1, 2 into 3 minus 6, expansion minus 2 3s are 6. So this is minus 7 into minus 2 plus 2, minus into minus plus 4 3s are 12, and minus 1 minus 7 into 1 minus 6, minus 7 into plus 2 minus 14. 12 plus 2 is plus 14 minus 14. You will get 0. So delta value is 0 if the two rows are identical. Similarly, if two columns are identical, we can find the determinant value is 0. That is property 2. Next, property 3. Next one is property 4. Fourth property. Property 4. Fourth property is, if the elements of a row or column are multiplied by a constant, then the determinant itself is multiplied by the same constant. That is the property. Just I state the property. If the elements of a row or column, if the elements of a row or column are multiplied by a constant, if the elements of a row or column are multiplied by a constant or a scalar, we can say that's constant by scalar also, multiplied by a constant, then the determinant itself is multiplied by the same constant. Multiplied by the same constant. That is the property. That is, if the elements of a row or column are multiplied by a constant, then the determinant itself is multiplied with the same constant. Consider a determinant delta. You know A1, A2, A3, B1, B2, B3, C1, C2, C3. This is the determinant delta, you know. Expanding through the determinant by R1, you know, A1 into B2, C3 minus B3, C2. B2, C3 minus B3, C2. As usual, expansion. Minus A2 into B1, C3 minus B3, C1. B1, C3 minus B3, C1 plus A3 into B1, C2 minus B2, C1. B1, C2 minus B2, C1. This is the determinant value of delta. Now I am multiplying the first row element by a constant k. Then I call it by determinant delta 1. Ka1, Ka2, Ka3. I multiply the first row element by a constant k. Ka1, Ka2, Ka3. Second row is B1, B2, B3. C1, C2, C3. Now expanding again using the first row, Ka1 into Ka1 into B2, C3 minus B3, C2. B2, C3 minus B3, C2 minus Ka2 minus Ka2 into B1, C3 minus B3, C1 B1, C3 minus B3, C1 plus Ka3 plus Ka3 into B1C2 minus B2C. B1C2 minus B2C. So, in this expansion, I get one constant K common from the expansion. I am taking the constant K out of this expression. Left hand side is the determinant delta 1. I am taking the value, the determinant is delta 1 is this. What is that? Ka1, Ka2, Ka3, B1, B2, B3, C1, C2, C3. If I take that common K outside, I get K into A1 into B2 C3 minus B3 C2, B2 C3 minus B3 C2 minus K, I am taking outside, minus A2 into B1 C3 minus B3 C1, B1 C3 minus B3 C1, I am taking K outside, plus A3 into B1 C2 minus B2 C1. B1 C2 minus B2 C1. This is again equal to K into the quantity within the bracket. You see, this is from 1, A1 into B2 C3 minus B3 C2 minus A2 into B1 C3 minus B3 C1 plus A3 into B1 C2 minus B2 C1. This is nothing but the value of delta. This is delta. From the expression 1. So delta 1 equal to K delta. The determinant value is itself is multiplied by the constant K. That is delta, you know, this is delta. From this expression I can get delta 1. This is delta 1 is right hand side. See. What is delta 1? This expression can be expressed as delta 1 is Ka1, Ka2, Ka3, B1, B2, B3, C1, C2, C3. This is delta 1 equal to K times of delta. Delta is A1, A2, A3, B1, B2, B3, C1, C2, C3. See, this is the property. Hence the property, because the elements of the first row are multiplied by the constant, it is equal to the determinant itself is multiplied by the constant. Or otherwise, the constant can be taken out of the determinant. That is the property 4. So the elements of a determinant are multiplied by a constant, then the value of the determinant is itself is multiplied by the constant. It is the property. If single row, here is the case which is different from the matrices. If in a matrix, each and every element should be multiplied by a constant, then only the constant can be taken out of the matrix. All the 9 elements should be multiplied by the constant K, then only the constant K can be taken out of the matrix if it is a matrix. Whereas in the case of a determinant, it is enough to multiply by a single row or single column by a constant. That constant can be taken out of the determinant. This is the major difference from the matrices. Matrices and determinant difference I have given you already. Here also you have difference. All the 9 elements should be multiplied by the constant, then only the constant can be taken out of the matrix if it is a matrix. Whereas in the case of a determinant, it is enough if we multiply a single row or single constant by a single column by a constant K or some other constant. That constant can be taken out. This in the case of the determinant. Okay. And I will give you an example for this property. This is property 4. if delta equal to 12, 18, 24 and 3 minus 1 0, 2, 4, 5. You can consider this determinant delta. Delta is the first two elements are multiplied by a constant 6, I can say. That is equal to, you can 6 into 2, this is 6 into 3, this is 6 into 4. 6 2s are 12, 6 3s are 18, 6 4s are 24. And 3 minus 1 0, 2, 4, 5. So by the property 4, if the elements of a row or column are multiplied by a constant, then the determinant itself is multiplied by the same constant. Therefore, I can take that 6 out of the determinant. I get 2, 3, 4, 3 minus 1, 0, 2, 4, 5. This is the property, fourth property. If the elements of your first two are multiplied by the constant 6, therefore the determinant itself is multiplied by the constant 6. It is the property 4, and this is an example for the property 4. This is the value of the determinant. It is enough if you find a value of this determinant and you multiply it by constant 6, you will get the value of this determinant. If you want, you can check. You just expand the determinant, you multiply the value by 6, it is equal to the value of this determinant. That is the property. If any row or any column, the elements are multiplied by a constant, the constant can be taken outside of the determinant, or the determinant itself is multiplied by the same constant. That is the property 4. We will stop here and we will continue in the next video from the next property. Thank you.